Hello everyone, my name is Rick Gurgitz. I'm the Complex Service Manager for the Red Power Stores. We're a group of 10 stores in northern Iowa. And welcome to my series of videos on combine settings, adjustments, and basically just trying to understand how our combine works. So over the years of doing combine clinics, it's great to give out information, but there's a lot to go over on how to make our combine work correctly and make your harvest go easier and better results. So what I've decided to do is I'm going to take basically the contents of a combine clinic and I'm breaking it down into different sections. We're going to do a section on feeder, threshing, cleaning and sieves, automation, just breaking it down into smaller snippets. So we're going to get them on YouTube clips that will be put on our company website, and you'll be able to go reference those whenever you need to. Because again, clinic's great, and I love it when all you come because it's really good interaction, questions, and I learn a lot from you as well as the other way around. And I want to make it in a more usable format for you as you go forward. So again, if you get out in the field during the fall and you're having trouble remembering a segment, you can go to our website, pull up that particular YouTube clip, run through it. You can speed it up, slow it down, back up, do whatever you need to. And again, as we go along, I need the feedback from you of what I'm missing. I'm just trying to do a general overview of what I think you need. But again, I can adjust these season to season if something new comes up and add or subtract, do whatever we need to. So thanks again for watching. We'll have, like I said, several different segments as we go through. Today in this particular segment, we're going to concentrate on the sieves, or the cleaning system of the machine. We've got different segments already done on the feeder house, threshing, but now we want to look at the segment. Once we've got our crop fed into the machine, we've done a great job of threshing and separating. Now we want to start looking at the grain pan rearward and through our sieve system. And what needs to happen in order to get this all completed and get the grain cleaned up and into our grain tank, get all other mog material out of the back of the machine. So we're going to start with the grain pan, talk about it a little bit. We've got key elements within our threshing, or separating of pre-sieve, and we have the upper sieve and the lower sieve. And we're going to discuss how they interact, how we set them. And we also don't want to forget our cleaning fan down there. Very important part also of how well the sieve system is going to work is dependent on our air blast and how it is moving its way up through the whole sieve system. So with that, we'll step up here and take a little bit closer dive into this and get started. So now that we're up here and we can see into our area a little bit for the cleaning system, our basic components we're dealing with is the active grain pan up in this area, and then back here, of course, we start within our sieves with the pre-sieve area, and then as we move rearward a little more, we've got this upper and lower sieve, and we'll get a better look at those after we move around to the rear of it. So grain pan, pretty basic component, just catches the grain as we're dropping down. Again, we're threshing a majority up here, starting a good separation also. And you can see the ridges in the pan, and that's what the concept of the active grain pan comes in. As it's moving the grain rearward, it's also shaking it and moving it up and down, which then stratifies the grain. So therefore, the heavier grain works its way to the bottom, all the loose mog material is working its way up. And then as we move back here and it starts dropping it down on the pre-sieve, pre-sieve is going to take the heavier grain that's right on the bottom, get it skimmed out essentially right away down into our clean grain auger, and then move the rest of the material back onto our sieve system. So pre-sieves, generally we're going to probably pull 20% of our grain out of the sample there, and then after that we're going to be moving the rest back onto the main system, or sieve system. So one important concept we have up here, not much maintenance at all on a grain pan, but if we get in a scenario, early season soybeans, corn, anything that's wet and sappy, or another scenario, if you happen to scoop up some dirt with your grain platform, and all that material will drop down on here. A lot of times it likes to stick to this grain pan. So if you take your side cover off, and this area is one big circle of heavy material stuck on there, best thing to do is take something similar to this and just scrape it loose. Get all that loose. The first time you start up the machine, it's going to move all that rearward. If we don't get that cleaned off and you have a perfectly flat surface in here, it's not going to move the grain rearward. All it does is just sit there and shake it up and down. and it doesn't start moving it rearward. So we definitely want to keep these little ridges visible and keep the material off of them. So that, other than the grain pan, we also look up in here for distribution as we come down off of the rotor. And again, it has to do a lot with pinch point, which is typically in this area. We'll take another look at that from the rear a little bit. Distribution is very important because we want our crop mat to be even as it moves rearward onto the Sieves system to give it adequate chance to do its job. So as we talk about the importance of the pre-sieve, and again, it's going to skim off about 20%, my estimation, of the grain that's coming back off of our active grain pan. The rest of the material is going to move on back onto the top sieve, and of course then through the lower sieve. But it's extremely important that we know we have our pre-sieve calibrated. So if we set it at 8 or 10, whatever the crop condition, that is actually where it's at, and it's supposed to be by millimeters. And again, this is for the in-cab system. We have a lot of our systems, older machines out there, still had the pre-sieve, everything works the same. The only difference being with those is we had a mechanical linkage rod down the right side of the machine out the back, and there's where we were adjusting to like notch 3 or notch 4. Those have a calibration process also, or an adjustment I should say, and we're going to delve into that a little bit later. But for our in-cab system, again, we need to be at 6 mil, quarter inch, as it indicated on the cal screen on the display. And I like to use, here again, our 6 mil bolt, and I like to get it so I'm laying it on one finger and it just slides underneath of there. Then I know I have a 6 mil opening. I can go up in the cab and hit the cal button on that screen, and it's going to remember that or reference that as 6 mil. From then on, if we go to 8, 10, whatever on our in-cab system, we know that's where it's going to be. So very important, and that's why I suggest at least checking that. Again, we can check this periodically through the year. If you happen to be on 8, we'll say for soybeans, get yourself, instead of this, get an 8 mil bolt, run the same test. You can run this in here, see if it's close, because pre-sieve adjustment through harvest, as I've mentioned many times, is extremely important. Because again, we want us doing its job to get the certain amount of grain off of this before it goes back to the main sieve. But more importantly is we don't want to get this open too far, because getting the pre-sieve too far open will allow grain to spill over into our cleaning fan. So if any of you had that situation where all of a sudden you have a bunch of grain in your fan, it can be caused by two things. Either our pre-sieve is open way too far, or we have the lower sieve so tight that the grain can't get into the clean grain auger quick enough, starts spilling over the front of the lower sieve, and again spills into the cleaning fan. So again, starts our air blast, everything's moving through here. Good cal on this, good pre-sieve, we're off to a good start. We're going to move the material then on back to the rear sieve. And we'll move around now to the back of the combine so we can get a better look at that. So these are the buttons we can use to either open or close the pre-sieve, of course, at any time that the key's on. But this is what works so well when we're trying to set up a cal, is you can have your finger on here, your other hand in here, open and close whatever you need to do to get your opening where it needs to be. So now we're looking at many of our machines. For years we used a manual adjust to the pre-sieve. Everything else we've talked about sieve-wise is the same on the older machines as far as calling it, the right, lefts, adjustments, everything identical. The only change on the pre-sieve, its function, what it's doing, sizing's the same, is whether we're a manual adjust or we went to the in-cab adjust. So again, we talked about with the in-cab, how we're caling that to the 6 mil. This one's a little different, but we still need to cal this so we know if we're on, typically we've always been notch 3 on beans, notch 4, occasionally 5 in corn, depending on what we're doing. How do I cal this? Well, it's fairly simple. We've got adjustment here, we can tweak this, or up here. We can lengthen and shorten that if need be. Well, how do I know where I'm at? Well, again, we can check very easily. Am I roughly at an 8 mil opening at beans on here? And we can adjust this to where we get there, because then when we go down here, should be about 10 mil. Might vary a little on this. Another quick, easy way is when I'm up here, are my fingers completely closed? And I would say this one's off a little, because look at this. I can go, my fingers are closed essentially there. Typically what I do is set that there, loosen this, roll pull this back and forth until the fingers on the pre-sieve up there are totally closed on notch. Essentially, we can call it notch 1. So a couple ways to do it. I mean, another easy one, again, go here, get your 8mm bolt out, move it back and forth. Is it where I want it to be? Adjust this back and forth until you get 8 mils on notch 3. Still coordinates with our in-cab system, even though it's mechanical. And then when we're down here, we need to be in the neighborhood of a 10 mil opening. Again, because we want the pre-sieve to do the same thing, whether we're in-cab or mechanical. So again, pretty easy adjustments, extremely important. Again, so many times I've seen situations where we have a issue cleaning or whatever, pre-sieve's off by a mile. If it's closed too tight, you're overloading the rear 2 sections of the sieve, because again, we have that active grain pan stratifying that grain moving rearward. The other side of the case, if we get the pre-sieve open too far, we're getting grain in the fan. So extremely important adjustment. So, as we're going to do a sieve calibration now, we can just simply start on the run screen. We're going to go to the back button. We're going to select calibrations. And then from the drop down, we're going to find cleaning. Here's upper, lower, and pre-sieve. We know our pre-sieve is where we want it. We've already got it at the 6 mil. And here again, simple instructions. Close the sieve completely, then open again to 6 mil or the 1/4 inch. We know where we're at. And this is really all there is to the calibration. We're going to hit OK. And that's all it takes. And then from that point on, when we go back here, we know if we make an adjustment here and we go to 6, it's going to be at 6. And then it also allows us, if we open up, and let's say we've gone to 8, and it's a little fussy sometimes because it doesn't really, when you're dealing with mils, it's not going to be that much. And then there we're at 8. See, it closes, opens, there, we're at 8. So, we're at 8 mil now, and we should be able to go back there, and we'll check it here in a minute. We can slide an 8 mil bolt in there, and we'll be correct. Now, we'll also, same procedure if we're going to do the cals on, that one's completed. We can select upper, exact same instructions. So what it allows you to do is you can go back and set all of them at the 6 mil, again with our handy little bolt. Set them all at 6 mil, and then you can jump up here and cal all 3 of them at the exact same point. So with this one up here, I already know it's at 6 mil, upper sieve's done, and of course then you would follow the same procedure for lower. And again, it's very important that we do these, and I would almost suggest doing them between crops, because in my experience working with customers, to me it seems like these cals will creep a little bit on us. And again, it just wreaks havoc with you trying to adjust your machine. So if you're talking with your dealer and they say, well, for corn, put your pre-sieve at 10 to 12, and let's say it just doesn't seem to work, and you go back and maybe you're getting grain in your fan. Well, if you check it with a measuring device or bolt, and suddenly you discover, well, heck, it's at 14, well, that's telling us our cal is off. So that's why it's extremely important that we follow our calibrations and do recalibrate them, so we know for sure that when we're running here and we have settings in there, it is actually doing what it's supposed to. So that's just kind of an overview on the calibration procedure for the sieves. Very simple, easy to do, but extremely important. So now as we're at the rear of the system, we can see into our upper sieve. Of course, the lower sieve is down below us. Cal procedure, again, the same as what we were just doing up there with the pre-sieve. Again, we have our 6 mil bolt. Okay, so as we're talking about calibrating our sieves, and again, this is similar to the pre-sieve, all 3 sieves adjust on the same, but we still have to get our original reference point set. Again, that's where we're using our 6 mil bolt, and we're going to open and close. We have switches right out here that will show you that you can open and close, and we want that bolt to just slide in there, just like that. I'm laying it on the finger of 1, just slides under the opening on ahead of us. And there's a nice 6 mil 1/4 inch opening. All we need to do then at that point is go up in the cab as we've shown on that calibrate screen and hit calibrate, and you're done. From that point on, it's going to use that. It knows, okay, that's 6 mil. So then as you open it to whether it be 8 or 10 or whatever crop we're in, it's going to open referencing off of that. And you can also see we have a bit of a scale right over here. And is reasonable as long as our finger isn't bent up, and it's kind of just about on 6 right there where we're at right now, so that's accurate for the moment. An extremely important part too to remember in this whole system is really on this upper sieve. We have 2 separate sieves with the divider in the middle. They are hooked together and run by one actuator, but there are some mechanical adjustments, you can't really see it, but they're down here and here, that synchronize the 2 of them together. And on this one, it's off just a touch. I'm looser over here than I am here with my opening. So that's something you want to check on all your machines of your own in case something has slipped over time, or if you've replaced one side or the other, is we have to make sure that we have our linkage, mechanical linkage now, that attaches it to the actuator, both of them adjusted the same, because there is a variance in it. So again, easy test, am I snug here? And is it the same over here? This one's off just a touch. Not a whole lot, but there's enough, and you can almost see it, that this side's open a little more. And trust me, this will greatly affect how your system works if we get out of balance like that a little bit when we start doing loss. So once we have the top done, the lower one is done also, but we have a door down underneath here. It's kind of hard to see. We'll take a shot of it from the side. We have to pull a couple pins and drop the door down to get at it, and it is hard to reach in there. I'm not going to lie to you, but it is equally as important that we get that lower sieve cowled also. Now again, we've got buttons on the outside here, and again we'll take a peek at them later on from the outside, but there's a flap out here. You can open and close your upper sieve here. That's what makes it easier to get your adjustment done. So as another reference point then, as we're harvesting, a lot of times we will, corn, a lot of times we're running 22 or so on the top sieve. Another way to test this to tell if your cal is correct, here's just a 20 mil bolt. And as we're harvesting, it's the same scenario. We're going to slide that in there and out of there too. And you're going to be in that same scenario. You get a nice, it's just right there. Another quick check to make sure that your calibration is still where it needs to be. Because again, sieve settings are very particular, and we're off 2-3 mil, it's going to make a dramatic difference on how things react. But just a quick, easy check again to make sure that we're pretty close, just like that. So another thought as we're looking at this big picture now is we can kind of see how our fingers are, the angle of them, and that's why really in my book 22 is about wide open for a sieve. On the upper and of course the lower we're never quite that open. But as we continue to open this and start getting past 22, so I think there's probably up in the 26 range or so. But what we've done, we just build a snow fence, because these fingers are standing up so straight all the way through all this area that the material really doesn't even want to flow rearward anymore. It really starts hanging up on there. So that's why I say typically, I got the right button, that 20 range is about as far as you're ever going to be, 20-22. And that should be adequate. If we got everything else adjusted correctly, that should be where as far as we need to go on any crop. Now the lower sieve, similar scenarios. Of course, you can't see it down in there. But on the lower sieve, some people say, well, I just open it wide open. I typically don't like doing that. I like, typically my lower sieve is always going to be 2 numbers below my upper. So if I have the upper one at 20, my lower one's going to be at 18, 16, 14, whatever the scenario is. Seems like that works pretty well, cleaning things up and reducing loss out the back. So as we look at that, your lower sieve also acts as a air louver to the top one. That's why I don't like huge differentials between them. You know, a lot of times if people start seeing material in their grain tank, then all of a sudden the first reaction, well, I just need to close the lower sieve. And there may be some of that we need to do, but historically your upper sieve should be doing the majority of the work. That, along with how we have everything set at the front of the machine. Again, sieves are never the cause of the problem. They're just back here trying to correct the crop mat that we presented to them. So typically, as long as we have our air blast working correctly, no mechanical deficiency, the sieves are just trying to catch up with what we're giving them. So again, if we're flooding our sieve with so much mog it can't keep up, probably not its fault. We need to get back up front and figure out what in the thresh process isn't working correctly. One scenario comes to mind right away, and as we discussed in our rotor threshing section, our friendly straight bars that help us so much in corn really don't do us any good in soybeans. The straight bars on the back of the rotor in dead dry soybeans really work against us because that straw just keeps getting pulverized over section 3 and 4, falls down basically kind of up in your pre-sieve area and ends up back here. Because in our good scenario, we want a lot of the material, of course, coming off of our upper chopper rotor. So it's going to be coming off the back of the rotor up here and then flying on out the back as rotor discharge, and that's what we want, the percentage. But certain crop conditions doesn't work as well. We get a lot more grind up per se, and we do end up with more of a load on the sieves. So if we got everything working correctly, this set we're cleaning, we can run our lower sieve pretty open, there should basically be nothing in the tailings. And that's what I've always said. If you've got your machine set correctly, your tailings auger should essentially be empty. We shouldn't be recycling that much. Anytime we're plugging tailings or doing something, we got a problem more so back up front that we need to address. So there again, that's what we're doing on the upper sieve. So just a couple quick cals, verify that we're the same right to left on this upper one, because it is 2 separate segments and it's adjustable. Once you get it dialed in, it shouldn't move unless something gets bent or hardware comes loose. But essentially that's what should be working back here. So then at the end, here's our sounding board that we have that essentially is going to measure any loss that is walking off the back, going to tap on this. This is how we're, what we're doing to adjust the tailings on the display that we showed up there as we're going through the field. So that's kind of what's going on here. As we look forward here, again, we have a self-leveling sieve system, and we talk about grain pan distribution, kind of dealing with the pinch point. So what we're looking at here is if we've got everything set correctly up front, we're going to have the majority of it hopefully distributed. It's going to be a little high on the right side and then fairly even the rest of the way across. Again, as our rotor is spinning, we always load the right side a little bit heavier. It's the way it's been clear back from the beginning of the 1460s. They just like to thresh up in that front right corner, and we can live with that. If we get scenarios where our distribution gets a little distributed, so in other words, if we get really deep on this side, or maybe the other way, depending on our pinch point, we can put an offset in our cleaning system. And there's a way to do that. We showed that in the display. But how do I know if I need an offset if I don't? Well, remember that if we're really going to do a loss check, we got to get our spreader up at the back of the combine. And if we think we're right side heavy, so in other words, our crop mat's really deep on this side, really tapers off over here. This side's doing a great job. This side's struggling to keep up. We can actually build an offset in here where this side's just going to ride a little bit high all the time to help shake that grain across as it comes reared off the grain pan. But the only way we really know if we need that is when we're doing a loss check. If we're hard or heavy distribution on this side, you're going to end up with a trail of grain over on this segment, clear over on this side when we're looking down below. And it's very easy to see as long as we have the spreaders up. If it's going through the spreaders, you're never going to be able to determine whether you're right or left side heavy. And that's where we put in typically a 1/2 degree plus. So if we put in a positive number, it brings the right side up. If we put in a negative number, it's going to bring the left side up. Very rare that we need to bring the left up. But typically, soybeans, you're not going to need anything, or wheat or oats, just because of the volume coming across it. Corn, you could probably be safe to put a 1/2 degree in. 8-row corn heads, probably not so much. 12 rows, yes. And I'm going to say the most you ever need is 1. If we get to the point where we think we need 2 or 3 degrees, then we need to go back up and start looking at that pinch point to see if it's way off. So again, we can tell distribution, and this is one place I'm never a big fan of kill stalls, but a kill stall will definitely, if you look in here after kill stall, you will definitely see your grain pan distribution and where it's laying there. So that is one aspect of that, and then we can kind of adjust from there. What I typically like to do though is go off of what your loss is behind you when you're windrowing. And then if we see we got a little bit of a trail over on that right side, we're going to put a 1/2 degree in it and see if that gets rid of it. Now I have seen the case where it was level and they put in, suddenly threw in 2 degrees and it immediately moved our trail that was drizzling out this side. It immediately went over here because we started moving it the opposite way. Once we put too much offset in here, it simply tilted it too much and we suddenly flooded now the left side and it was leaving a trail. So on that one, again, as the grain gets drier, 1/2 degree is all you need to try, and that will really move that a lot. About grain pan distribution. Again, it just depends on, we're always wanting to dump heavy on the right side, just the nature of the rotation of the rotor. So it's very important whether our distribution is level, like this, or like this, because as the material moves rearward, it's really going to affect how well our sieves work, depending on how level we have this. So this is one area where a kill stall will really show you the difference. I'm not a big fan of kill stalls most of the time. Usually I like to figure it out more from our loss out the back, but this is one place that really shows what you've got going on. Now, a kill stall on your sieves doesn't do much good because the moment you shut everything shut off, all the grain starts falling down through here, and you really can't see much back here because it all falls through there. But up on the hard pan itself, that's where you can see your distribution. Again, it's a function of our pinch point. Now typically we want our pinch point somewhere right in this neighborhood, just about 6 o'clock, 5 to 6 o'clock. That's where our heaviest thresh and distribution is. Then as we move rearward, it'll spread itself out. So again, pinch point is something we want our technicians adjusting. I mean, there is adjustments on the other side, but you really got to know what you're doing to keep the concave bed level and know where you've actually got it set at. So, but that's kind of just an overview of what we got for distribution. So earlier we talked about adding a sieve preset, or an offset I should say. When we get to that, is we're going to go back here to the toolbox. We're going to go to cleaning. I'm going to scroll clear to the bottom. Here's sieve offset, and we can put in, again, this one happens to have a 0.5 in it, brings the right side up. If we need, and you can set this to negative, that would bring the left side up. My recommendation typically is just to start at 0 to start with, especially in soybeans, and you can change this between corn and soybeans. A fairly safe bet, because these machines do like to throw heavy to the right side, just from the centrifugal rotation of the rotor. Historically, clear back to 1460, they want to load the right side a little heavier. You're fairly safe to start with a 0.5 in corn. I would not do any more than that, but for soybeans, I'd take it back out. Just get rid of it, go back to 0, because with that yield amount, even if it is loading a little to the right, you're better off to try to run that level. So again, we need to get to offset, toolbox, cleaning, and it's clear down at the bottom where you get at to add or take out an offset. But again, don't get carried away with that. It can cause just as much damage as good, because I've seen many cases where, oh my God, I got a little trail on the right side, and we come in here and we put in 3. Well, you're going to move that trail to the left side in a hurry. So again, very careful with that. Don't add too much till we know, and we've done a good yield loss check behind the machine. So to access the lower sieve, you've got 2 push pins right here, or I should say 1 on either side, and you open that up. This door and this flap will flap down. Then you can reach down in there. Can't really see it, but you can reach up in there. Again, you want that longer bolt. You can actually maybe work better with 2 people. Open and close that sieve, get your cal value in there, and then you can go up in the cab and complete it. But it's, again, you got to drop this door down. Make sure you reclose the door, of course, when you get done. And then there's a flap up in here that has to get pushed back up in there, but it does give you access to that lower sieve for the cal. So one other element we don't want to overlook in our cleaning system, of course, is our good old cleaning fan down here. Not a lot to talk about here other than keep the grain out of it. Doesn't like that. We do have on the newer ones, we have the clean outdoor. If you happen to have a little bit older machine, they didn't give you that option. But again, very important part, keep this screen area clean. It does suck up a lot of material as the year goes on, depends on the crop, the wind, how things are coming off here. If we really start packing this in, the screen underneath, it starts robbing that fan and almost kind of tries to run in a vacuum. So again, good daily cleaning with your leaf blower will help alleviate that situation. But we don't want to overlook our fan. The only other thing I've really seen over time that can affect them a lot is if we develop an oil leak on either side and we get oil inside this chamber and we coat the blades on that fan with an oil film and it starts collecting dust, or occasionally sucrose too, with chopping corn heads can create that. You wouldn't think it'd make that much difference, but once those aluminum blades in there get coated and start building up, it greatly reduces the amount of air that we're moving. So don't overlook that sometimes. If it seems like our fan's maxed out on speed, not doing what we want it to, take a quick look, make sure it's still clean in there. It could be power washed out. Open the door, let the water out, start it up, let it dry off. But again, very important part, or a component of our cleaning system. So one other key thing I want to touch on, we're on the clean grain elevator side of the machine, is after we've got our cleaning system set to the way we want it, everything's happy there, we got to make sure we have our elevator in the correct speed for what we're doing. A lot of these will come shipped from the factory on the low side. So let's look at our drive system for the clean grain elevator. Belt driven, we have a driver down here, basically the other end of our chopper shaft, 2 sheaves here, an idler, 2 sheaves up here. They come from the factory in the low side, and that's just the way they've been shipping them. You definitely want to be able to shift back and forth between the crops. We definitely want, for corn anymore, we want to be on the high side. Some people tend to leave it there, but I would suggest going back to the low side for elevator wear when you're in a lighter crop, soybeans, oats, and whatnot. It does require a little bit, you got to loosen the tensioner up, and you got to hop the belt between sheaves. So it's not that difficult to do. There's our tension right here. But you can also, when we do this, so we're going to hop from high to low. We're on the high side now, and then this is the slow speed. But this bushing right here on the idler also has to get moved to the other side. Otherwise, if we move this belt here to here, we're not really lining with our idler. If I get that lined up right, we're going to be over here, and the belt's trying to run crooked. So when you move this, you also have to move that idler spot, or that bushing, to the other side in here. Now, in my thought is, why didn't they put a double wide pulley in here so we don't have to monkey with that? I'm currently working on that. I think I've got it figured out, a different pulley that we can put in here with some different bushings. So then when we move this, you don't even have to touch this. You would simply loosen this up, and sometimes you can almost cheat with a vice grip and hop that over, but otherwise our tensioner for it is right here, and then you can slip them back and forth. I think it's extremely important that we are moving that over. We definitely got to be on the high side in corn, because what I have seen in many cases lately, we got this running in the low side, we get in a heavy corn crop, the clean grain auger cannot keep up moving the grain out of the sieve system and getting it into the elevator. So what we end up with is we flood the lower sieve, we start choking the air off, go into the upper sieve, and we just have a heck of a mess then. We can get grain into the fan. That is a second way that we do that. We talked earlier that if our pre-sieve is set too wide, we can get grain in the fan. A second way is if we flood the lower sieve and the grain simply has nowhere to go, it will spill over into the clean grain, or excuse me, in the cleaning fan. So again, very important, make sure you're in a high speed on this for corn. And whether you shift back to low for beans is up to you. I still say that the yield monitor impact plate works better in soybeans when we're running this on the slow side, simply because the quantity of grain hitting it is more coordinated with each paddle coming around. But for the main thing, at least make sure you're on the high side for corn. And again, big driver, Small driven gives us high side. Small driver, big driven gives us the low side. So just a quick overview on that. I wanted to point that out of what's going on there. So, quick overview, we have the buttons on the side here. That's what I was reaching through from underneath there. You can reach up here. Of course, this is open, close for the upper close for the lower. Typically don't use these a lot unless we're cleaning something out of the sieves, but again, we're using them all the time if we're going to be in that cal process to get it exactly where we need. So one other item to look at in the display will be our calibration or adjustment, I'm going to say, of our sieve loss funnel. And of course, it's just using that sounding board that's on the rear of the upper sieve. That's what it's using to determine if we have loss coming out the rear. And again, I can't show you a real full display of this because we're not actually harvesting. But your sieve loss funnel, of course, is over here. This is the icon you use to adjust it. Again, it's going to yell at us because we're not actually harvesting, but we can go in and physically change this value. There is no one set number where you need to start at. You're going to be in the middle of this range historically rather than in extremes. And what we're shooting for is, don't let the funnel tell you how to set the combine initially. And I repeat this over and over again on different segments. You get bored of hearing it. Go out and adjust your machine the way you always have, manually. Establish your losses out the back. So in other words, we're going to have to go out and do a loss check. And once we're happy with the way the machine is performing, from front to rear, and we're happy with what grain loss we may or may not have out the back, we're going to go in and adjust this funnel percentage to where we have a little bit of green in the bottom. That way, as we're harvesting along, we know, okay, this is my set point, everything's fine. If something goes awry and our funnel starts filling up, then we know, hey, I better get out and look to see what the problem is and why it's not working right. So that's just an overview on what to look at for how we're going to adjust this sieve loss. Same is true of the other funnels. Same scenario with threshing loss or rotor loss. We've got some other ones here. This is broken grain camera portion. Tailings, again, this does play into our sieve segment. And same scenario, if we have our machine set correctly and the sieve set correctly, everything's humming, there's nothing in the tailings. So a lot of times I heard many customers freaking out because, oh my God, my tailings have gone way up. Well, depending on how we have the sensitivity set on this, again, is going to tell us, is there really anything in the tailings? Do I need to be concerned? Majority of the time, the answer is no. Because again, tailings means that we're running material over that lower sieve and it's going into this grain processor, tailings processor on the side. So that's what that one is. And then this one is MOG, or basically, again, a grain camera function and how much material is in the grain going in the tank.
Hey, thanks everyone for watching. This brings us to the end of this video segment. I hope you found it to be beneficial. If you would like to see more in this video series, by all means go to the Red Power Team website, which is of course at redpowerteam.com. Navigate up to that video icon at the top, and from there it'll bring up the menu of the rest of the videos that you can watch, whichever ones you find interesting. Thank you.